Normally on this YouTube channel, I try and talk about some of the biggest issues in climate change, some of the most important climate research that you need to know about. But today I figured I'd do things a little bit differently and talk about some pretty obscure research. My own. So this week marks 10 years since I started my PhD in atmospheric physics at the University of Oxford. In other words, it's been a full decade since I've been working on climate change in one way or another. So to distract myself from the aging process, I figured it would be fun to look at what my thesis was all about. So I worked on rain. You see, for everything from our farms to our cities, rain is incredibly important. But unfortunately, it's also incredibly hard to accurately predict how rain will change as we heat our planet up. For comparison, let's first look at how temperatures across the globe have changed over the past decades as we've changed the climate. You can see that pretty much everywhere on Earth has got hotter on average. Now compare that with the same plot, but for rainfall, and you can see that it's a much messier picture. Some areas have got wetter, some areas have got drier, and some areas it's hard to tell with the data we have. So rainfall changes are just really complicated, but they're also really difficult to simulate in computer models. The point of climate models is to simulate all the physical processes that affect the climate, so things like atmospheric circulation, evaporation of water, stuff like that. Climate scientists then use these models to simulate what the planet would do in different circumstances. For example, what the climate would look like if we added a bunch of greenhouse gases to the atmosphere. Like that would ever happen. These climate models help us learn a lot, but they're also far from perfect. A big part of the reason for this is because they have limited resolution. So just like an iPhone camera can't take a perfect picture of what someone's reading 2 miles away because of its limited resolution, climate models, because of their limited resolution, can't perfectly simulate all the tiny processes that lead to rainfall. Because of these limitations, climate models have mistakes in their simulations. We can see this in their predictions for the future. So different climate models will disagree about where we'll get wetter and where we'll get drier. And if you're trying to plan for the future and you don't know whether to expect more rainfall or less, well, you can see why that might be a problem. But climate models don't entirely disagree, and in fact there are some pretty key things that they agree about. And it was my PhD to see whether we could somehow adapt these models to uncover some kind of hidden agreement between them. This is why I find it super weird when climate skeptics are like, you climate scientists don't want to admit that all climate models are flawed. It's like, what? My entire climate science PhD was about the fact that climate models are flawed. Okay, but back to the question I was exploring. How exactly was I hunting for this hidden agreement between climate models? Well, imagine you're looking at the global rainfall pattern, and then at one particular blob of rainfall in particular. Now, perhaps one climate change model always simulates that blob too far north, and another climate change model always simulates that blob too far south. Now, even if both climate change models agree that that blob is going to get wetter in the future, when you overlay the climate models, it's going to look like they disagree because they simulate the blob in different places. So what if you could move all the rainfall blobs around to get them into the right places? Well, then maybe that would reveal that climate change models do actually agree with each other much better about where's going to get wetter and where's going to get drier. To do this, I needed the kind of techniques that are used to morph one person's face into another person's face. I actually borrowed these techniques from medical imaging, so I was splitting my PhD time between the atmospheric physics department and the MRI department of the university hospital. taking these techniques which were developed for studying people's brains and using them to study rain involved doing a lot of maths and then a lot of coding. Please do not ask me to explain what any of this means. I do not remember. I forgot pretty much as soon as I could. What's even more amazing to me than the fact I actually wrote all this stuff is the fact that all this stuff actually worked. I showed that moving all these rainfall blobs around did reveal hidden agreement between climate models about rainfall, and that correcting for the location of all these different blobs could help us predict the future of rainfall. I presented my findings in conferences and in 3 published peer-reviewed academic papers, and during my doctorate I also started this YouTube channel so that when I finally passed my 3-hour PhD examination, I could call myself Dr. ClimateAdam. And just a couple of months ago, a full decade since I started my PhD, my research was cited in the latest IPCC report, the most important climate change report ever written. You can click up here if you don't know what I'm talking about. Now, full disclaimer, the IPCC reports cite pretty much all climate change research that isn't nonsense. But nevertheless, it's still pretty wonderful to have this confirmation that my research isn't nonsensical. So if my research got the results I was hoping for and is now officially not nonsense, why did I leave academia? Well, I should firstly say that academia is incredibly competitive, and I have absolutely no idea whether I could have actually made a career in it. But secondly, during my PhD, I realized I enjoyed talking about and sharing research more than actually doing my own research. And so that's what I do now. Whether it's on this YouTube channel or through my science journalism, I get to do what I love, sharing important scientific and climate information with people like you. So yeah, today's video was a bit different to usual, but I figured I could not pass up this 10-year anniversary opportunity to talk about my PhD research. Next time though, we'll be returning to normal, and I'm looking at some of the most fundamentally important climate change research out there, specifically on sea level rise. You do not want to miss that video, so make sure you are subscribed, and if you want to help me keep making videos long into the future, then you can become a patron over on Patreon. Okay, that's it for now. Until next time. Bye. Oh my god, it took so many goes to get that right, you have no idea.